Some say, save the best for last. Teacher Josie is giving the best now. Let's recall the steps in solving system of linear equations using substitution method by doing this activity. In plus sign, we have cramming. Below it, we have check. In minus sign, we have skipping classes. Below it, we have substitute. In multiplication sign, we have procrastination. Under it, we have variable. And in division sign, we have being disorganized. Under it, we have value. Cramming, skipping classes, procrastination, and being disorganized are some of the poor study habits that you should avoid or eliminate. Remember the word eliminate. It has important role later. Now, let's do the activity. We select our answer from the one written in caps lock. Check, substitute, variable, and value. Number 1. Solve for one blank in terms of the other variable in one of the equations. If one of the equations already gives the value of one variable, you may proceed to the next step. The answer is variable. 2. Blank to the second equation, the value of the variable found in the first step. Simplify, then solve the resulting equation. The answer is substitute. 3. Substitute the blank obtained in equation 2 to any of the original equations to find the value of the other variable. The answer is value. And 4. Blank the proposed solution in both equations in the system. The answer is check. Let's solve the system 4x minus y equals 7 and y equals negative 3x plus 14. Since y is already solved in terms of x in equation 2, we substitute negative 3x plus 14 for y in equation 1. So this is equation 1. We now substitute 4x minus y is negative 3x plus 14 equals 7. Copy 4x. We apply the distributive property. So negative times negative 3x is positive 3x. Negative times positive 14 is negative 14. Copy 7. We combine similar terms. 4x plus 3x is 7x. 7 plus 14 is 21. We added 14 to both sides of the equation so that on this side, we only have the x terms. Dividing both sides of the equation by 7, our x is 3. We now substitute 3 for x in either equation 1 or 2 for us to have the value of y. Let's say equation 2. Y is equal to negative 3x plus 14. So y is equal to negative 3. Our x is 3. Copy y is equal to negative 3 times 3 is negative 9 plus 14. So what is the value of y? It is 5. So we now have the coordinates of the point 3, 5. Let's check if 3, 5 is really the solution of the system. In equation 1, 4x minus y equals 7. So copy 4, our x is 3, minus our y is 5, is equal to 7. 4 times 3 is 12. Copy minus 5 equals 7. 12 minus 5 is 7 equals 7. Do we have a true statement? Yes. Next, equation 2. Y equals negative 3x plus 14. Our y is 5. Y equals negative 3. Again, our x is 3 plus 14. So, copy 5 equals negative 3 times 3 is negative 9 plus 14. Copy 5 equals negative 9 plus 14 is 5. Do we have a true statement? Yes. 3, 5 satisfies equation 1 and equation 2. Therefore, 3, 5 is the solution of the system. There are systems of equations which are difficult to solve using substitution method, but can easily be solved by another method, which is elimination method. Here are the steps. Step 1. Whenever necessary, rewrite both equations in standard form. So again, the standard form of linear equation is ax plus by equals c. Step 2. Whenever necessary, multiply either equation or both equations by a non-zero number so that the coefficients of x or y will have a sum of 0. So in this step, we will determine which variable to eliminate. Step 3. Add the resulting equations. This leads to an equation in one variable. Simplify, then solve the resulting equation. So solve for the variable. Step 4. Substitute the value obtained to any of the original equations to find the other variable. So in this step, we substitute in either equation 1 or equation 2 to find the other variable. And step 5, check the values of the variables obtained against linear equations in the system. So substitute your ordered pair into both equations. Let's have example 1. Solve the system 4x minus y is equal to 7 and y is equal to negative 3x plus 14. So step 1, whenever necessary, rewrite both equations in standard form. Equation 1 is in standard form already. What about equation 2? Rewriting equation 2 in standard form, we have 3x plus y is equal to 14. Step 2, whenever necessary, multiply either equation or both equations by a non-zero number so that the coefficients of x or y will have a sum of 0. The y's have opposite coefficients. We have here negative y and positive y. Next, add the resulting equations. So adding the two equations, we have 4x minus y is equal to 7 plus 3x plus y equals 14. Variable y is eliminated. So 4x plus 3x is 7x. 7 plus 14 is 21. Dividing both sides of the equation by 7, we have x is equal to 3. Step 4, substitute the value obtained in any of the original equations to find the other variable. Let's say in equation 1. So y is equal to negative 3. Our x is 3 plus 14. So y is equal to negative 3 times 3 is negative 9 plus 14. So y is 5. Step 5, we check. For equation 1, so 4, our x is 3 minus Our y is 5 is equal to 7. 4 times 3 is 12. Minus 5 is 7. So we have 7 equals 7. True. Next, for equation 2, our y is 5 equals negative 3. Our x is 3 plus 14. Negative 3 times 3 is negative 9 plus 14 is 5. We have 5 equals 5 is a true statement also. The 0.35 satisfies equation 1 and equation 2. Therefore, the solution of the system is 3, 5. Let's have another example. Solve the system x plus y equals 5 and negative x minus y equals 7. So, we check our two equations if they are in standard form. And they already are. Do we have opposite coefficients? The x and y's have opposite coefficients. We are now ready to add them. Adding the two equations, we have 0 is equal to 12. And we have a false statement. Remember, in solving system of linear equations using algebraic method, when the resulting equation is true, the kind of system that we have is consistent dependent. So the number of solutions is infinitely many. When the resulting equation is false, the kind of system that we have is inconsistent system. So, in this system, we do not have a solution. Let's have example 3. Solve the system x plus 2y equals 6 and 3x plus 3y equals negative 6. Looking at equation 1 and equation 2, they are already in standard form. What about the coefficients of variables x and y? We do not have opposite coefficients. And so, we will multiply a non-zero number in either equation 1 or equation 2 or both for us to have opposite coefficients. Let's say we want to eliminate x. What are we going to multiply for us to have opposite coefficients? So we will multiply equation 1 by negative 3 to eliminate x. Multiplying equation 1 by negative 3, we have negative 3x minus 6y is equal to negative 18. Copy the second equation, 3x plus 3y equals negative 6. Adding them, we have negative 3y is equal to negative 24. See, variable x is already eliminated. Again, negative 6 plus 3 is negative 3. Negative 18 plus negative 6 is negative 24. Dividing both sides of the equation by negative 3, we have y is equal to 8. So, substitute 8 for y in equation x plus 2y equals 6. X plus 2, again, our y is 8, is equal to 6. X plus 2 times 8 is 16, is equal to 6. Our x is equal to negative 10. We added negative 16 to both sides of the equation, so that on this side, we only have variable x. 6 plus negative 16 is negative 10. We applied the addition property of equality. Remember the golden rule of equation. What you do to one side, you must do to the other side. Let's check. In equation 1, our x is negative 10 plus 2, our y is 8 is equal to 6. 2 times 8 is 16. Negative 10 plus 16 is 6. So we have 6 is equal to 6, true. Equation 2, 3, our x is negative 10 plus 3, our y is 8 is equal to negative 6. 3 times negative 10 is negative 30. 3 times 8 is 24. So what is negative 30 plus 24? It is negative 6. We have negative 6 is equal to negative 6. It is a true statement also. So, negative 10, 8 satisfies equation 1 and equation 2. We say that the solution of the system is negative 10, 8. Let's check if you really understand our lesson. I want you to work on these two items. Do it in any sheet of paper. I will give you 1 minute to do it. Let's check your work. What is your answer in number 1? The correct answer is letter A, since we have opposite coefficients of y. What about number 2? Do we have a solution of the given system? I have here with me the solution for number 2. We have the value of x, 1, and the value of y is negative 2/5. We have the solution of the given system, 1, negative 2/5. Did you get the correct answer in number 2? Very good. Let us see if you already mastered the steps in solving system of linear equations in 2 variables by elimination method. You are going to arrange these sentences. Game Kanaba music will be played. When the music stops, you check your answer. Ready? Step 1. Whenever necessary, rewrite both equations in the standard form ax plus by equals c. Step 2. Whenever necessary, multiply either equation or both equations by a non-zero number so that the coefficients of x and y will have a sum of 0. Note, the coefficients of x and y are additive inverses. Step 3. Add the resulting equations. This leads to an equation in one variable. Simplify, then solve the resulting equation. Step 4. Substitute the value obtained to any of the original equations to find the value of the other variable. And step 5. Check the values of the variables obtained against the linear equations in the system. Did you get the correct steps in solving system of linear equations using elimination method? Job well done. Did you save the meeting information? This is bye-bye time, and I'm leaving with you a quote. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. Keep loving numbers!